Yo. Welcome to 4.8. 4.8 is all application questions, aka word problems. And I'm going to focus on two of them in this lesson in 4.8. The two kinds of questions I'm going to focus on are questions that have to do with directions, in other words, with bearings. And I'm going to focus on questions that have to do with harmonic motion. These are all trigonometry questions. One of them is solved by, just basic SOHCAHTOA, but it's a little more complicated. And the second one is solved basically through graphing. And I did it again. I said basically so many times. I need to stop saying basically so much. And so, I say so a lot. So, there are two different ways in which directions can be measured by either captains of ships or pilots of airplanes. And so we're going to go over those two different methods. The first way has to do with surveying and navigation. They describe directions in one way. And the second thing has to do with airplanes. With airplanes, they describe directions a little bit differently. So we're going to take a look at just how they do that so you understand. In surveying and in navigation, bearings measure the acute angle that a path or line of sight makes with a fixed north-south line. For example, the first picture here would be a bearing that is read 30 degrees east of south. So let me go over that again. Here you have a fixed north-south line. And with respect to this line, what angle do we have? This is east. So this direction right here would be described as 30 degrees east of south. 30 degrees east of south. And the way you would write that is actually like this. 30 degrees east of south. So the first letter tells you that it's going more south than north. The second part tells you the actual degrees of the bearing from that fixed line. And then the last letter tells you if it's east or west. Let me just give you one other one. For example, if I were here and this was 60 degrees, I would call this south, 60 degrees west, and I would read it 60 degrees west of south. If I were up here and this was, let's say, 50 degrees, I would call this, well, I'm going mostly north and I'm also going west, and then I would have a 40 in there. This is 40 degrees west of north because the angle is always measured with that straight up and down north-south line and the direction that you are heading. So this obviously would be 40. So this is read 40 degrees west of north. Okay, now I want you to try to do these. So what do you think these would be? You write it down, pause the video, and do it. Okay, did you write this? So first of all, it's mostly north. Secondly, this angle here is 60 degrees. And lastly, it's going more west than east. So I would say this is 60 degrees west of north. Yeah, you got it. Good job. This one's also north. And let's see, this is 70 degrees in here. So this would be 70 degrees east of north. And that's what those should have been. How'd you do on that? Good. We're going to be doing a word problem with that in just a second. But before we do, let's talk about airplanes instead. So that's what you do with surveying and with navigation. That would be boats, for example. And with air and navigation, they do it a little bit differently. And you're going to see both of these in your exercises. With air navigation, bearings are measured in degrees from clockwise from north. So this is a little bit simpler, really. This would be 60 degrees. The bearing 060, that's what they say on an airplane. And bearing 240, and that means they're going in that direction. And here I'd have bearing 330, or just that. So that's all they would say in airplane. In navigation or in a boat, they would probably say something more like here. They would say 30 degrees west of north. That's what they'd say. In an airplane, they would just say bearing 330. Okay, so those are two different kinds that you're going to run into. So let's do a word problem now together. And be very careful on this one. You're going to have one just like this in your assignment. A ship, all right, because it's a ship, we're going to use the navigation ones that we did earlier, leaves port at noon and heads west at 20 knots, which is nautical miles per hour. At 2 p.m., the ship changes course and goes with this bearing right here, 54 degrees west of north. Find the ship's bearing from port at 3 p.m. Okay, so we're going to find out what the ship's bearing from port is at 3 p.m. So first we're going to draw this picture. So let's say that the port is right here. I'll call it P. And we know that he goes west for the first 2 hours. So because from noon to 12 is 2 hours, and if you're going 20 knots, which is 20 miles per hour basically, then we know that this ship would have gone 40 nautical miles here. So that's 40. So after 2 hours, it then changes course and goes in that direction. Find the ship's bearing at 3 p.m. Okay. So I'm going to go ahead and I'm going to kind of put some north, south, east, west things here. And 54 degrees. Okay. So let me draw that right about there. So that's the direction it's going to go because it says 54 degrees west of north. That implies that this angle right here must be 54 degrees. You okay with that? And at 3 o'clock, the ship is now right there. This distance here, of course, is going to be 20 as well because it went 20 knots for 1 hour. All right, now the question is find the ship's bearing at 3 p.m. Okay, I'm going to connect these two right here. And what I'm looking for is the ship's bearing. In other words, its direction. So I'm going to kind of put this here. And I think you guys can tell that the ship is kind of heading north overall, but not very much. It's heading mostly west. So my answer is going to be that it's heading north some degrees west. So some degrees west of north. That's going to be my answer because it's going kind of north and kind of west. I just need to figure out what this angle is. And that angle specifically is going to be this one. So that's where my answer is. So how in the world am I going to do that? Well, when all else fails, start drawing some lines in there. Okay. Do I know how much this is? No. Do I know this angle? Yes. That one's 36, isn't it? 36 degrees because 54 and 36 are 90, and this is together 90. So those are complementary. I need to find that distance. Oh, I know. Maybe I could do this. So make a nice little rectangle out of the whole thing. See, I got a nice rectangle. Do I know this distance here? No. Do I know this distance here? No. Do I know this distance here? No. So if I don't know any of those distances, it's going to be pretty hard for me to find that angle. So I'm going to start finding some distances, okay? So let's just start by saying, okay, I'm going to find this one. I'm going to call it X. And this one's pretty easy to find. I know this angle is 36, and I know this is 20. So with respect to the 36, that is the opposite. That's hypotenuse. So I could say that the sine of 36 equals X over 20. You guys all good with that? So do a little cross multiplication and stuff. And I'm going to get that X equals 11.8. All right. So that's helpful. Oops, not 11 equals 8. 11.8 equals X. All right, now I'm going to do this one. I'm going to call this Y. And what I mean by Y, I guess I'll be more specific. I want that guy. Do I want that guy? Would that help me? I'm trying to think if this would help me. Yeah, it would help me. Okay, so I'm going to find Y too. So with Y, with respect to the 36-degree angle, it's the adjacent. So I could say that the cosine of 36 equals Y over 20. And that would give me a Y value of 16.2. Okay. All right. So that tells me that this big old thing right here is 56.2. All right. That seems to be all the information I need to go ahead and find that angle because I'm looking for this angle right here, which I'll call theta. And with respect to theta, I have an adjacent and I have an opposite. So now I can do it. So I can say that the tangent of theta equals opposite over adjacent. And therefore, I'm going to use the arctan notation. The arctangent of 56.2 over 11.8 equals, I don't know what it is. So I'm going to go ahead and put it in here. The arctangent of 56.2 divided by 11.8. And I'm going to estimate it before I press enter. So it looks like it's like 70 or 80 degrees. Some of you guys gave me some absurd answers on the quiz. So make sure you estimate. So it should be between 70 and 80. And yeah, I'm getting 78. So I'm getting 78.1 degrees. So that angle is 78.1 degrees. So my answer is that the bearing at 3 o'clock from port is the ship has overall gone 71.8 degrees west of north. All right, so that's how I found that bearing. You had to find a lot of stuff to get there. In your assignment, it's also then going to ask you questions such as how far did the ship go? And if it's asking you how far did the ship go, well, at this point you have a right triangle. It's easy. You'll just do 56.2 squared plus 11.8 squared equals c squared. And actually, I did do that, and that gives you like 57.4, and that's how far it's gone. So you could be able to say the ship is 57.4 miles away from the port at a bearing of 71.8 degrees west of north. Can you handle that? I think you can. One of the keys is just to start drawing all of these north, south, east, west lines and creating right triangles, and then using those right triangles you created and SOHCAHTOA to find missing angles and missing sides, and eventually you'll have everything you need. Okay, there's a part B to this, so come back for a harmonic motion. I'll see you soon.